right, so chapter 6 uses a lot of what we learned in chapter 5 and gives it some more application to the real world. So we're going to talk about probability distributions, and the book does a nice job about, defining it and all that stuff. We already read that. I'm not going to rehash that and have you rewrite it in your notes here. We're going to jump right into an example. So suppose we're interested in the number of heads showing up with 3 tosses of a coin. So if this is the prompt that we're given, we know that the possible outcomes are 3. 0 heads, or sorry, 4. 1 heads, 2 heads, or all 3 heads. And so when we list this out, we're going to have possible results over here. We're going to have our first toss here, our second toss here, and our third toss here. And then over here, we're going to have the number of heads. So let's say we start off and we get tails for all of our tosses. Then we have 0 heads, right? And we keep doing this, and we find that we have tails, tails, and a head. So now we have 1 head. The third one, we've got tails, head, tails. So again, we have 1 head, and so on and so forth, right? 4, tails, head, head, 2 heads, 5, head, tails, tails, 1 head, 6, head, tails, head, 2 heads, 7, head, head, tails, 2, and 8, all heads, right? So from this data, we can now figure out a probability distribution, right? We know there are 8 possible outcomes. We know that 2 out of the 8 are associated with, or sorry, not 2. Man, I'm having a hard time counting today, right? 3 out of the 8 are associated with 2 heads. We know that 3 out of the 8 are associated with 1 heads. We know that 1 out of the 8 is associated with 3 heads. And then we know 1 out of the 8 is associated with 0 heads. Do we all understand how I got these relative probabilities, the probability of the outcome? So we looked at all of the different results. We counted up the number of results there are. That's what went into the denominator of all of these fractions. And then we counted up the number of outcomes that were associated with each number of heads. Okay. So we then take this data and we put it in chart form. We put it in graph form. So on the x-axis, we're going to have number of heads. We're going to have a 0 value that's not on the origin, which I know is kind of strange. But 0 is a category here, not necessarily a ordinal value. So whenever 0 is a category, you're going to want to give it a little bit of space from the origin. 1, 2, and 3, right? We have 4 different outcomes. So these are the different outcomes on the bottom, and then we have the probabilities on the x-axis, or on the y-axis. So we have 1/8, we have 1/4, we have 3/8, and then we have 1/2. And so now we're just going to be putting, okay, with 0 heads, that's 1/8. So I'm going to have this little bar chart go up to 1/8. And then the number of heads, well, we know that for number 1, right, for 1 heads, it's going to be 3/8 probability. For 2 heads, it's also 3/8 probability. And for 3 heads, goes back down to 1/8. One of the checks that we can do, since we know that the events of 0, 1, 2, and 3 are mutually exclusive and collectively exhaustive, since we know that, we are going to assume that these all should equal 1, right? That 1/8 plus 3/8 plus 3/8 plus 1/8 is going to equal 8/8 is equal to 1. So the sum of all the probabilities, since they're mutually exclusive and exhaustive, the sum of all the probabilities has to equal 1. Questions on probability distribution tables? That's what this is called. Well, this is actually a probability distribution graph. Questions on that?